Play mode.
Hello, welcome to the webinar Washington Trust Bank VDI Best Practices for Mobility Storage and HADRS. We're lucky to have Chris Green, the VP of IT Infrastructure at Washington Trust Bank, with us today. Chris has been doing IT for 30 years in the areas of computer technology, systems engineering, and technology management. In the 11 years prior to joining Washington Trust, Mr. Green held positions in IT management, computer consulting, and technology education for companies in Spokane, Washington area. His experience also includes a 15-year career with the United States Air Force and 6 years as a research and development engineer assigned to projects designing, integrating, and testing computer navigation weapons delivery systems for state-of-the-art military aircraft. So with that, I'm going to turn it over to Chris, and he's going to begin the webinar.
Great. Well, thanks for that introduction, Seth, and I also would like to extend my welcome to all of you that are tuning in for this webinar here. I know there's a high interest in VDI. Different companies are at different stages of that process. Some of you may already have a virtual desktop infrastructure in place. Other ones are maybe in the process of testing. And some may be just looking at this as a potential future technology for your organization. I think we'll have something here of interest to everyone that is attending right now. So moving forward, for Washington Trust Bank, what were the business drivers for moving to a virtual desktop infrastructure? Back in 2003, when I came to the bank, our CIO and I were discussing the desire to move to a thin client model, at least at some level within the bank. The goal, of course, was traditional benefits one would receive from thin client computing. Those are kind of highlighted in bullets 2 and 4 here. Basically centralized management and control of your desktop environment, and also finding some operational cost reductions in the process. Now, I have to admit that back in 2003, our focus was primarily on our teller lines. We thought that that would be the best place to deploy thin client technology. However, as we started doing some pilots back then in that area, we discovered that the current technology in combination with the specific front-end teller application and the peripherals that we need to support, the thin client technology just wasn't there at that point. So we kind of shelved that and stayed on with thick PCs across the board. Starting last year, we determined we were going to do a Windows 7 migration across the bank, and as part of that, we kind of pulled the thin client concept off the shelf again and kind of dusted it off and said, well, let's take another look at this. Maybe this is an opportunity for us to move forward with this. However, in the interceding years, things had changed, both from a technology perspective. Thin client, now kind of more virtual desktop infrastructure had matured, and we actually said, hey, wait a second here. While this might be a good thing for the teller platform, we could really use this to enable our mobile workforce. In other words, let's target this to our knowledge workers and get those knowledge workers out from behind the desk and out into the client sites. And so some of the business drivers for the mobile workforce, of course, is to provide that mobility, to facilitate that mobility, and then security. Security is huge, and I'll talk to that here in a minute. So anyway, the security piece, customer data loss, obviously a huge risk for banks. It's a huge risk for a lot of companies, you know. And as we all know, lost laptops certainly increase that risk. We've seen a lot of articles in the news about customer data, proprietary information being compromised because laptops were lost. Obviously, in the financial institution, compliance is huge. I mean, even more so in the last few years. The regulations and compliance requirements for financial institutions has just grown exponentially. Data loss protection obviously being a high focus on that. And, you know, and in the area of data loss protection, you know, while lots of customer information, yes, that's a huge piece of it. But there's also, I think we can all agree, there's a lot of other types of compromised data that can really hurt a company. For instance, maybe losing some information, some documents that might be relative to a confidential merger or acquisition. So data loss protection, I think, is applicable to everyone. And so this is where VDI comes in, I think, and really helps us out here, because it eliminates at least a large portion of the security issues relative to a mobile workforce, because the data never goes on to the mobile device. It is still held centrally within the data center. And that's really an important piece of all of this, because obviously, rather than trying to manage several hundred or several thousand, you know, laptops or mobile devices and trying to lock them down and keep them secure, now we can just centralize that, just focus on securing the servers and the infrastructure that's in the data center. So there's definitely benefits, and VDI certainly facilitates the security aspects. Going on to the mobility aspect, as I said, we decided that VDI, our VDI deployment was really something to focus on our knowledge workers. And so, again, to give them the mobility moving between offices, moving between branch locations. We currently have 42 branches and remote offices across the Washington State, Idaho, and Oregon regions. And we quite frequently have knowledge workers that move around between locations. Also, being able to grant them access anywhere that they have an internet connection is definitely a plus. So maybe they want to meet with a client down at the local coffee shop. Well, as long as they can get an internet connection, they can bring their desktop right there to their mobile device and present to their client documents and papers and charts, whatever they need to do, without having to figure out how do I download these onto my laptop or whatever. And also, what's nice about this mobility piece is the VDI is pretty much device agnostic. As long as we can get a VMware View client onto the device, then it enables the knowledge worker, the remote user, to access their desktop no matter where they're at. So just a little bit about Washington Trust Bank, our business organization, and some VDI models. We are a privately held commercial bank. So commercial banking is a primary core competency of ours. And along with that, we have a significant private banking and wealth management presence that's kind of linked to that. You know, a lot of our wealth management, private banking clients are also commercial banking clients, as they are tend to be business owners. We also handle, in the wealth management area, trust funds, trust accounts, things like that. And then our third line of business is retail banking, which is typical branch banking that most people are familiar with. And the retail banking not only supports a base of consumer banking customers, but also supports the previous two lines of business as well. So as we begin to approach our Windows 7 virtual desktop infrastructure project, one of the things that we had to do was to go out and take a look at what are the applications that are in use along not only these three major lines of business, but all the support groups as well. And then there's quite a large bank support function that supports all of these. For instance, human resources, our accounting group, and things like that, IT. So we had to look around what applications are in use, and also what peripherals are in use. So are there going to be any odd type of peripheral devices that would be problematic in a thin client, shall we say, environment? So in our IT department, we have business analysts who are assigned to different lines of businesses and support groups, and they spent several weeks working with each of those groups as a group, and also individually with people in those groups to define, specifically what these things were. Now, we found that we are supporting right now around about 100 primary applications, major applications that are in use across the bank. Some are common across all lines of business. Some are unique to specific lines of business or support functions. And all told, we discovered after completing our inventory that we actually have around 500 applications that we support here within Washington Trust Bank. Some may be only used by one or two people, but all told, around 500 applications. So obviously one of the big challenges here is doing the application validation piece within both Windows 7 and in a new platform, the VDI. So we spent quite a bit of time doing that. Once we had that in place, we were able to take the different departments, lines of business, and specific users, and figure out which model were they going to go into a non-persistent pool, or were there some requirements that were maybe unique to a given individual that would require us to provide them with a persistent desktop. And so once we kind of went through all of that, we kind of knew kind of how many pools we were going to need, how many persistent desktops we were going to need, and so at this point in time, we were ready to kind of start more or less architecting the system physically to support that. During the process, this actually was what I would call a pre-production mobility use case that and these things I think we can all relate to, they kind of sometimes crop up on us, and we were actually well into the testing phase, actually the final part of our testing phase, but before we had really pulled the trigger on moving to production, we got a request from our retail banking group, which kind of organizes, manages our home loan center. That's a consumer product, so it falls under retail. And their mandate to the loan advisors was to get out of the main office, move around between different branches. And so what they had done is they had assigned loan officers, loan advisors to 2 or 3 different branches, and they were to go and move around between those. And of course, the goal in doing this was to better serve existing loan customers, and to also look for opportunities to service new customers in the areas of home loans. So before VDI and under our traditional model, this would have created some issues. Definitely some IT management overhead involved in this, and also some end user kind of challenges. First and foremost, we would have to ensure that all the loan applications and all the supporting applications for those loan advisors were installed on at least one PC in every potential location that they were going to go to. So that definitely was a challenge. Secondly, once they would go out to these locations and log in, then they have to pull down a roaming profile, which in many cases could be quite large, and it definitely slows down the performance. So when they approached us with this, like I said earlier, we were in the late phases of testing, and we thought, hey, what better way to test this as we're kind of gaining confidence in this than to actually put it out in the hands of some real end users. And so we approached the management of our home loan center and said, would you guys be willing to kind of beta test a new technology that we are going to be bringing bank-wide? We think we can actually make this mandate of yours, at least from a technology perspective, a lot easier. So they agreed, and so we developed a home loan center pool, if you will, and made it available to those loan advisors that were going to be moving around. And actually, it was received quite well. People were quite impressed that they could move around between branches and log in quickly and have the exact same desktop that they had both at their main office and also in the remote location. So this was really an encouraging result for us, and kind of spurred us on. So getting back to the VDI initiative, what were some of the requirements as we were looking at this project? And the first bullet point there, I think, is really important. Again, technology continues, as it has for years and years, to just accelerate. The consumer technology sometimes outstrips the commercial technology. In other words, quite often you find that your end users have technology in their homes that's advanced beyond what you have in the office. But long story short, people are used to, when they get a new piece of technology, that new piece of technology has to be better than the previous one. It has to be faster. It has to have more functions. It has to have a better user interface. And this is what people have come to expect. And so we knew going early on out of this that we would need to provide an end user experience that was at least equal, but hopefully better than the physical PC performance. People have different change profiles too, and I think as IT management people, we run into this, and we can all agree, we see this all the time, is that people get very comfortable with the particular piece of technology they have, and certain users have a very flat change profile, and so moving them to a new piece of technology is problematic, shall we say. So to smooth that transition out, if you can actually give them something that's newer, better than what they had before, it really helps to kind of get over the hump with changing those things. So that was really important to us. Obviously, since mobility was a driver for us, having a high-quality user experience over the WAN is important, particularly we're talking about going out to client sites. We're going to have a client sitting at the table looking at this. We don't want to have a poor refresh performance, and we want it to look really good and present a good face of Washington Trust Bank to our clients as well. Again, mobility between devices, both within the bank and outside the bank, was important. And again, we felt that all of these things were critical to achieving user acceptance and making this project a success. You can see down here at the bottom of this slide a little prompt here, a little anecdote of in our accounting group. We rolled out the VDI here just a couple of weeks ago, and after we had done that, a young man came to me and he said, well, I've been at the bank about a year now, and when I came here, I asked if I could have remote access from home with my MacBook, and I was told no, that wasn't possible. And in the previous kind of architecture, shall we say, we had it wasn't, because we had to control all of the remote endpoints very closely. We only allowed bank-owned devices to be used remotely, and so that way we could control antivirus, the encryption on the laptops, all those things to maintain the security around it. So anyway, he approached me with that question, and can I use my MacBook? And as it says there, the answer is yes, you can. Go to the Apple Store, download the VMView client. He already had remote access, so he had his RSA token, and everything was set up on the firewall for him. So it was just really a matter of downloading that client and pointing him to the URL for our View Gateway server, and he's off to the races. So that was really interesting. Again, this is sort of getting into and we'll talk about this a little bit more about the bring your own device, or BYOD, and while that is not a formal policy of the bank as yet, a piece of this is also kind of looking out there to trends that are coming, and not running down into any blind alleys. Kind of keeping your options open, I think, is important to us. So what was our initial VDI design? What did it look like after we had kind of gone through our inventories and kind of determined what applications and peripherals we were going to have to support with this environment? This is the fundamental design that we came up. We're going to use VMware View. When we started out, it was a version 4. We're version 5 by the time we went to production. vSphere 5, we were going to leverage ThinApp. There was a number of applications that we came across during our inventory process that just lent themselves very well to the VMware ThinApp process. Of course, high availability and dynamic resource sharing was important to us, again, to keep the availability high, obviously, and then also to keep that end user experience up there at a level that we anticipated and that we desired to have it. DRS would play an important function there. On the back end, for storage, we plan to use an EMC CX4 fiber channel fan that we already had in place. It actually is supporting, we have a highly virtualized server environment. We're running approximately 220, I think, servers in a VMware ESX environment that are also using the CX4 fiber channel fan. So we had planned to leverage existing infrastructure resources to support the storage requirements for VDI. we're primarily a Dell shop when it comes to workstations and servers. And so the Dell R710 was our desired host platform. And we decided, after looking at some different thin client computers that were out there, we decided to go with the WISE P20 Zero client and also the WISE laptop form factor client for us. And so this kind of gives us what we had planned to go with. So the VMware View client with the PC over IP, again, the PC over IP is very important to that end user experience because it minimizes the amount of traffic that flows between that remote desktop and the back-end infrastructure. As I just mentioned, P20s, Zero clients, and mobile thin clients were kind of our corporate device standard. Of course, there was legacy devices out there. We had a number of newer laptops and desktops that were still on the books, if you will, that we wanted to continue to use until their values had formally depreciated off the books, and we were at a point we could do a hardware refresh. The laptops we currently had are locked down with BitLocker. We run Windows 7 Enterprise, and we use the BitLocker hard drive encryption on those. And then for those legacy devices, we just use a VMware View client on a, call it a traditional workstation or laptop environment. Bring your own device, BYOD. I kind of touched on that earlier. And again, while it is not an official corporate policy of the bank, we're already seeing the desire to use personal devices, and again, we kind of anticipated this. Part of the reason for our justification for moving to VDI is that it would enable this, and so one of the other things that we brought into the environment was mobile iron to manage multiple devices. We can use Apple devices, iPads, iPhones, Androids, Blackberries, whatever. We're able to manage through that. So with this multi-platform device management in conjunction with VDI really enables the support of a wide range of mobile devices here. And again, like I said, it's not a corporate policy of ours, but again, as IT professionals, I think one of the things we always try to do is say, okay, what's the current business requirements? We obviously have to meet current business requirements, but we also try to think out ahead. Well, okay, what are the future requirements? How can I meet current business requirements, and then at least as best as I can look in my crystal ball and say, okay, what else is coming out there? And I think BYOD, it's certainly a hot topic that's out there right now. I guess time will tell and see how it actually plays out. But I think it's going to be an important factor in IT support. And so positioning ourselves to support that early on kind of prevents us from having to scramble down the road. So what's our mobile connectivity strategy? Okay, so we have these knowledge workers that are out there, and they're moving around, and if they're in a branch or a remote office, so that's easy. We have a wide area network that connects those out. They can just more or less plug in or use one of the WISE P20s at that location. Great. But when they're out of the office, there's the need, obviously, to connect to the internet in order to gain access to the VDI infrastructure. So the first thing is within the laptop or the WISE thin laptop, we'll use an integrated Wi-Fi, and they can just connect to whatever internet service that is available, either at home or in a hotel or coffee shop, whatever. We also provide all of our mobile workers, along with either their laptop or their WISE laptop. We provide them a 3G or a 4G broadband card or MiFi. And this provides really good performance when using PC over IP. The 3G is kind of our standard right now. We just have a few users now that are just migrating into the 4G world. But I can say unequivocally the 3G is very sufficient. It's more than sufficient for good WAN performance using PC over IP. I haven't had anybody complain that their performance was really poor or anything like that. So 3G is certainly good. 4G obviously better. So anyway, and again, PC over IP, by minimizing that traffic between the mobile device and the back-end infrastructure is really really important for us. So moving back here, okay, so and probably one of the things here, getting around to the subject of this this webinar here. Moving from pilot to production. Okay, so we went through pilot, we went through testing, we even put our home loan users, you know, probably 20 or so users out there in pre-production, and everything was working really good. Performance was good, and we were really encouraged, and so we had sized our storage for 500 users based on recommendations from our storage vendor. So we began to roll out the VDI, the Windows 7 and VDI, and to our surprise, we reached about 90 users, and we hit a tipping point from a performance perspective. And what we were seeing when we had about 90 active users on our system was a significant degradation in performance during peak usage times. One that you would see every day was during business opening hours when you get these login storms. Everybody's coming to work at 8 o'clock. They're starting to log in, and it would just really tank the system. And then at different times during the day, we would kind of see some other spikes, shall we say, in performance degradation. So, of course, the first thing is, okay, what's going on? We believe we sized this thing appropriately. Where's the bottleneck? What's going on? We looked at CPU, processor utilization. Long story short, we saw the spiking was due to I/O bottlenecks, and that was really quite a surprise to us. That caught us a bit off guard because we thought, well, certainly a cluster of 710s on EMC CX4, that's going to give us, you know, plenty of throughput. We certainly never had any problems, you know, in our server environment. So, you know, what's going on here? But we definitely found that was what the problem was. So the question then, the follow-on question, once you find out where the bottleneck is, well, how do I resolve that problem? So going back to storage vendors and talked with a couple other consultants, their recommendation was you need to add storage processors and preferably with solid-state drives, and that will solve your problem. And that's what I call the sledgehammer approach. That's, you know, basically let's throw massive amounts of hardware at this, and that will solve your problem. And it probably would have solved the problem, but the capital expense costs for us were just something that if we were going to have to put another 100,000 into additional storage to solve this problem, we were probably just going to shelve it and say, you know, this project is dead. We're going to stick with our traditional technology and maybe revisit this again. However, I began looking around on the web, and in a forum I saw somebody was talking about this IOPS issue and had mentioned in passing a company called Atlantis Computing and their ILIO device. So I popped on over to their website and read about their solution to it, which is a 100% software solution, and it definitely intrigued me. So I contacted them, and after several discussions, we decided to give this a try. At least let's put this in our test environment and kind of see if this indeed would solve our problem, because it definitely what I would call a more elegant solution to managing input-output issues. And so with that, I'm going to bring Seth back into here to kind of help me along with some of the specifics relative to VDI storage sizing, and why was it that we ran into this I/O bottleneck while we had thought, doing our best design work, that we had come up with an appropriately architected solution.
Thanks, Chris. So, as Chris mentioned, a lot of customers run into this problem, and the VDI storage sizing is fairly complicated and not well understood by most people deploying VDI. So one of the issues is that the VDI workload is very different from any other workload. Particularly, it's different from the server virtualization workload. So people expect it to behave kind of like server virtualization, but it's very different. One of the key differences is that the I/O profile is 80% write and 20% read during kind of the steady state when people are logged in. And that means that the storage system has to be able to handle a large number of random 4K write IOPS, which storage systems are not typically designed to do that, or general purpose storage systems. And then people also don't factor in there's a concept of front-end IOPS, which is how many IOPS you need per desktop to deliver the performance you're requiring, versus the amount of disks that are required on the back end and the IOPS required on the back end. So what people often overlook is that rating the storage system, which most storage systems will use RAID 5 or one of the other RAID levels, and introducing RAID into the equation means that you have a heavy write penalty. So in Washington Trust's case, they were using RAID 5. So that means that for every write that you have to the storage system from VDI, which is 80% of the traffic, you have to write that same block 4 times. And that means that you have to buy many more disks than you would originally think. So that's kind of what happened in the case of Washington Trust. So the original recommendation from the storage vendor was that they could deploy 500 users on 15K SAS drives. Now, if you look at the math of that, and you look at the RAID penalty of write, that means that they were expecting that they could get, you had 40 write IOPS per disk times 15 disks is 600 write IOPS, which is only 1.2 write IOPS per desktop. A physical desktop has 150 IOPS per desktop, so you're talking a minuscule fraction of what a physical desktop is. And going back to Chris's original point was that you're trying to deliver a desktop that's a new technology and make it equal or better than what you had before. So this was the fundamental disconnect. So and maybe Chris can talk to this, but they basically hit that wall at 90 desktops. And if you look at how many IOPS per desktop that means, that's 6.6 IOPS per desktop, where they started seeing really kind of terrible, unacceptable performance. So Chris, I don't know if you want to speak to that, like what were the symptoms that you saw as you added these users and how that happened?
Yeah, well, and this analysis here definitely fits with what we were seeing from a back-end management and monitoring capability. Because during kind of slow times, those 90 desktops were fine. People might have had an application open, but they weren't really extremely actively involved. But as I mentioned before, for example, during login times during the morning, there's a whole lot more reading and writing that takes place during there, and so we very quickly begin to overdrive the storage system because of this very factor right here.
So just to kind of hit home on the write IOPS penalty, there's a little animation here. So for every read, if you go into the storage system, there's only one I/O to disk. So if you advance that animation, you'll see that as that goes to disk, there's a single one. But for every write that's generated on the front end, on the back end, there's 4 writes to disk, which means that as this is happening across 500 desktops, the number of writes is magnified by 4. So if you look at how, if Chris were to go back to the beginning and do the math, the correct way to achieve the 20 IOPS, so if you look 20 total IOPS on the front end, which by the way is very low, remember that a physical desktop has 150 IOPS, so 20 is kind of the bare minimum that we would size for with customers. So if you look at it, you take 20 total IOPS, 20% of that is reads, so you have 4 reads, and 80% of that is writes, so you have 16 writes. So then you factor in the RAID 5 penalty to the writes, and that magnifies the number of writes you need to 64. Now, if your back-end IOPS, you add the total of the reads plus the total of the writes, and you have 68 IOPS needed per desktop. So if you look at, an estimate of 180 IOPS for a 16K SAS drive divided by the number of IOPS per desktop, you need, for every fiber channel SAS disk you have on your storage array, you get 2.65 desktops. So if you look at that from 500 desktop deployment, you're talking 188 SAS disks, which obviously is very different in terms of the total cost of the entire project compared to the original 15 SAS disks that Washington Trust was planning for. So that'll double the cost per desktop at least. So if you look at this in terms of the graphics on the bottom, per desktop you have 4 reads on the front end and the back end. You have 16 writes on the front end, but 64 writes on the back end. So if you look at that from what you need from a storage array perspective, instead of needing 10,000 IOPS, you actually need 34,000 IOPS on the back end. So that is essentially the problem with VDI storage sizing that Washington Trust ran into, and many of our customers that we come in to fix a stalled or underperforming VDI deployment with a very similar problem that's rooted in the IOPS from storage. So let me give you a quick introduction to what Atlantis Elio is. It's a software virtual machine that is an OVF, and it gets imported into Virtual Center in 8 minutes. There's no agents or changes to the desktop image. It's designed for a vSphere platform and plugs into that. There's no change to the overall architecture. So you'll see later, Chris will take you through how things worked with Atlantis. But it supports view, thin-app, persona for the profile, linked clones, full clones, any combination of the VDI deployment method. And essentially what you're going to get in Chris's case is you'll both get about 5 times more users on the existing storage. So he topped out at 90 users and then has storage that will get him to 500 users. And then it will support, he's doing a combination of stateless and persistent deployments. And it'll accelerate and solve the user experience problems because you're going to be delivering more I/O on the front end without having to tax the storage system on the back end.
Yeah, absolutely. And you know, long story short, once we put Elio in place, and we'll discuss here in a minute just some of the specifics relative to that, it did certainly solve our end user experience problems.
So let me give you just a little visual of kind of what the impact is. So, you know, at you have the hypervisor, in this case vSphere, on the left with Windows 7 desktops. They're generating a tremendous amount of input and outputs per second, or IOPS. That's the blue chart there. Atlantis is a virtual machine that sits on, typically it's on the same server as the desktops, and it becomes the NFS or iSCSI data store, and then it connects to whatever the back-end storage is. In the case of Washington Trust, they were using fiber channel with an EMC CX4 storage on the back end. So what Atlantis is doing is it's basically offloading the difference between the blue traffic and, on the back end, the red traffic on the chart. And the way it's doing that is it's processing the I/O out of memory on the local server for all of that duplicate traffic generated by the Windows 7 operating system and the applications that are built into the image, which account for roughly 90% of the storage traffic. At the same time, it's doing inline deduplication. So also, you know, anywhere from 90 to 99%, depending on whether you're a persistent or non-persistent desktop, will be eliminated in terms of storage capacity. So instead of 5 terabytes, you'll be using less than a terabyte on the back end. So we'll look at those results from Washington Trust in a second. But that's essentially what Atlantis Elio does.
Exactly, and I just want to add here to the folks now, these graphs that are on this, the performance graphs that you're looking at here, these are actual graphs from our performance metrics, and so you can see it's very dramatic reduction in I/O that's actually hitting the storage area network.
So let me go back to the math around sizing and look at how that's affected by Atlantis Elio. So again, let's say you're sizing for 20 front-end IOPS. You do the same math where you have 4 reads and 16 writes required on the front end. However, before you get to storage, Atlantis is going to remove some percentage of that. Now, it could be anywhere, up to 90% of the reads and writes. So in that case, you would subtract that percentage from the front-end I/O, and you get 0.4 reads, so you're 1/10 of the reads and 1/10 of the writes. Then you apply the same RAID 5 penalty because you're using the same back-end storage, and your total number of writes is 6.4 writes instead of 64. And then you combine them, and instead of 68 IOPS, you have 6.8 total IOPS to size for. So in this case, you can do 26 users per fiber channel disk. And if you go back to the design for the Washington Trust 500 user deployment, you can do that with 18 15K SAS disks. So if you look at that, with our graphic that we looked at before, again, you have the reduction in reads, the reduction in writes, and then you have that RAID penalty. So instead of 40,000 IOPS, instead of 40,000 IOPS approximately, you're talking 3,400 IOPS. So that's how you get the reduction in disk and solve that problem. And at the same time, on the front end, you're providing more IOPS per desktop and lower latency, which combines to provide that better user experience and gives you those extra IOPS you need during the peak times, like login, to make sure that everybody has a consistently fast user experience.
Yeah, and again, this just matches up very well to what we're seeing in the actual environment. It really smooths out those login storms that we see every morning. Just kind of flattens it out to it just has become a non-issue for us at this point. So a little bit about the Elio deployment. What does that look like? You know, Seth had mentioned it's a VM that actually sits in your environment. So it's a very simple deployment. You just import the OVF into vCenter, run the setup installation. It essentially inserts the Atlantis Elio onto your server as a guest VM that presents itself as an NFS share to the VMs that are on that machine. Of course, you collect the Elio to your back-end physical storage processor, and then as you create VMs on the host, the Atlantis becomes the NFS share that you point these VMs to. So from a high availability standpoint, this is kind of our current architecture right here to provide high availability. Essentially, the model is that there's an extra standby host within the VMware View cluster. And so if we get to a failover situation, simply use a DRS that just migrates over to the standby host. Should we have a failure on one of our hosts, it can just migrate the VMs and the Atlantis. Since the Atlantis product is just another VM, it just migrates along with all the other VMs on the host. Okay, so what are some of the test results? And again, getting specific here with some stats. I don't suppose this stat comes as a surprise after looking at some of these other things, but yeah, 875% increase in IOPS available. That's an astounding figure, and again has really opened up the ability to support our desired number of desktops in our current storage environment. Again, just supporting that. This is actual graph from our back end showing the IOPS here, and if you'll notice the timeline here, it runs from 5:40 in the morning to about 8:30. We are spanning a couple of different time zones here, Pacific and Mountain time zones. So we have people logging in anywhere from typically from about 6 to around 8:30 is our typical login times. And so if you look through between 6 and 6:30, you see that the IOPS are very, very low. It's really flattened out the back-end storage requirements significantly for us. And storage reduction. I mean, very, very big. Had we gone with the Sledgehammer approach and added more disks, not only would we have to get the fast disk, expensive disk, but we'd have to get a whole bunch of them. We would be looking at about 5 terabytes capacity in order to support 500 users. Obviously, that's a huge amount. So now we're down to, with the Atlantis Elio product, we're running about 800 gigabytes to support 500 users. Again, a significant storage reduction and reduced cost. Getting back to performance here, latency. Great, fantastic reduction in reading and writing response times. Here, obviously, lower is better, and so this is kind of what we're seeing on average right now. It dropped from 26.03 milliseconds, 48.52, and then this is with 90 users. Now we're seeing an average of 4.6 and 4.24, or 4.24, and also throw into this is with more users too. So not only did we reduce the average read-write response time, but again, we're able to support more users with this. So I know we're running out of time here, so we'll try to wrap this up here. But what are some of the lessons learned from this whole endeavor? Well, okay, one of the things that we want to keep our end users happy. Our end users' success are our success. That's what we're here in the IT business to do. We're here to enable our businesses to do their jobs. And if we're transparent to them, that's a good thing in my book. So we want to be able to support the business initiatives and do it effectively, efficiently, and with a high degree of reliability and availability. Secondly, plan for bring your own device. Even if you're not implementing a formal program as of yet, it's kind of on the horizon. Again, as I mentioned earlier, if we, as IT people, we try to balance current requirements and also keep an eye to the future so that we don't run down any blind alleys for when that time that the CIO, CTO, CEO, whomever comes to you and say, I'd like to do a BYOD program. Can you support that? I always like to say yes when they come to me for those kind of things. Mobility. Simplify mobile delivery. This is a big thing, and something that I think kind of goes a bit under the radar sometimes with VDI. I mean, a lot of VDI initiatives are focused on reducing OPEX, maybe some CAPEX expense, but mobility and mobility is a huge thing, and VDI can really simplify and facilitate supporting a mobile workforce. Again, eliminating security risk. The VDI, great. Keep it in the data center, shall we say. And then as you're approaching your VDI project, beware of the storage sledgehammer. Again, as we've seen quite clearly, VDI has some unique requirements, and if you're not careful, you can just walk over your storage requirements really quickly, and your only answer is to add more storage or find a more elegant way to resolve that. So anyway, just some resources here that you might want to check out relative to VDI if you're kind of either working on that project right now, thinking about it, even if you're in it right now and you're wanting to optimize your current environment. These resources are really good.
Yeah, Chris, I'd just highlight one of these resources, which is the myvirtualcloud.net VMware View Calculator. That is one of the best sizing calculators and will take care of a lot of the math that we did in the section where we were explaining why this happens. And it does have an option to factor in Atlantis or without Atlantis and different RAID levels and all sorts of even host sizing. So I would highly recommend that link, and then the Windows 7 IOPS white paper is kind of a technical deep dive on why Windows 7 consumes so many IOPS and what the patterns of I/O are. And then the VMware and Atlantis Elio reference architecture, if someone's looking for kind of like a blueprint to deploy either a persistent virtual desktop or a non-persistent virtual desktop, that document includes kind of a bill of materials, blueprint, server specifications, and other materials that you could use to build out a new VDI deployment.
Yeah, that second bullet. I mean, the first one is a great tool. Obviously, I totally agree with that. And the second one, that's a very important piece of this. You might have a virtual desktop infrastructure in place right now, and you're running Windows XP. You could really get caught unawares if you don't really take a look at the Windows 7 IOPS. Windows 7, in short, generates a whole lot more than Windows XP. So you might think, oh, we're doing good, doing Windows XP. We're just going to just migrate everybody to Windows 7. You could definitely tank your storage subsystem very quickly.
So Chris, we're on the hour that we had scheduled. If you're willing to stay on, I can. There's quite a few questions. So
yes, absolutely.
Okay.
Absolutely.
So let me start going through these. One of the first questions was, were there any regulatory issues around deploying VDI? What, did you do an analysis of that, and what were they?
Well, absolutely. There's regulatory issues around deploying any technology within the bank. Essentially, as we looked at VDI as an alternative to both internal desktops and enabling a mobile workforce, we had to look very carefully at were there any areas where we would be so-called decreasing our security posture, opening ourselves up to some vulnerabilities maybe that we didn't have in the past. And actually the answer was no. In every case, really moving to a virtual desktop infrastructure by, again, maintaining the desktops within your secure data center, and then minimizing what's actually on your endpoints from a data perspective. It really enhanced security across the board.
Okay, the next question was kind of, you touched on it, I think, when you were talking about mobility, but, how did you design, or what did you provide in terms of two-factor authentication for your mobile users?
Oh, yes. Okay. Well, prior to this, we had a small mobile workforce, and we use RSA tokens, and we have an RSA server to do that piece of the validation. So we've continued to do that. That RSA integrates really well into our VMview portal, shall we say. So in the past, what we used for remote access was a Cisco VPN client, which again you'd have to pull up the client, log in. It would ask you for your RSA token number, and then you'd also have to provide your domain credentials as well. That hasn't changed. It happens the same way. What's nice about this, though, is it removes the whole VPN, separate VPN access. Because before, like I said, you'd have to set up a VPN access and then go to a terminal server or remote to a desktop. Here, you launch the VMview client. If you have two-factor authentication enabled, it'll first ask you for your token ID, whatever, and we've actually moved to soft tokens now on the smartphone, so people don't have to carry around a physical fob, and you enter that number first, and then you move on to your domain credentials. So that's how we've implemented that, and it's very easy to do.
The next question was around mobility between your branches, and what kind of bandwidth do you have between branches, and are you using any WAN optimization tools to make that work better?
Yeah, that's a very good question. Actually, the bandwidth we have depends on the location. We have some large remote offices. For instance, our office in Seattle is probably one of our larger remote offices. There we have about 50 users, I think, that work out of that office. For that office, we have a 50 megabyte pipe, just because there's a lot of users there, and bandwidth is cheap in the big metro areas. We want to give them more than they need, so we don't have any problems there. Getting down to the other end of the spectrum, our branches, we're currently just wanting a 1.5 meg T1 to all of our branch locations. We use basically MPLS WAN architecture, but from a bandwidth perspective, we just have 1.5 meg to those locations, and that seems to be more than sufficient in a branch environment where you might have 5 or 6 users on there, and we certainly haven't seen any degradation of performance. Are we using any WAN optimization tool? At the current, we are not using any particular WAN optimization tools, but to just add a little piece into WAN bandwidth and traffic, most of our remote locations, particularly branches, run applications remotely. In other words, we have an application server, and our front-end teller applications actually have the server application piece of that resides locally. We do run voice over IP, so we are running some voice over IP traffic. We do put traffic shaping on our network to provide prioritization of traffic in order to make sure our calls are good. But other than voice traffic, there's pretty much just some file sharing traffic and stuff that goes on. So basically, we've just done some traffic shaping, but we haven't really put any particular traffic shaping in the branches just specifically for the virtual desktop infrastructure, and we haven't run into any problems with that as of yet.
Okay, thanks. The next few questions are related to Atlantis Elio, so I'll take them, and then I may ask for your comment on a couple of them. The first one was they wanted to understand how Atlantis Elio works with persistent desktops. So Atlantis works the same way with persistent as non-persistent desktops. We're the NFS or iSCSI data store for the VMDK of the persistent desktop. So, and then after the Atlantis Elio inline deduplication, the persistent desktop is roughly the same size and capacity as a non-persistent desktop, and you also get the benefit of offloading the I/O. So one of the things that a lot of customers like is that the persistent desktops without Atlantis consume a tremendous amount of capacity, anywhere from 20 gigs to 80 gigs per desktop, depending on your image. But with Atlantis, that gets reduced down to less than a gig per desktop. And Washington Trust is a good example of that. They have a majority of their users are persistent desktops, but they also have non-persistent desktops, and both of them go through the same Atlantis Elio virtual machine, and both use the same back-end storage. So there's a single kind of storage system for both types of deployments. Now, if you're only non-persistent, there are different options available, like Atlantis Elio diskless VDI, or using local disk. So diskless VDI is running all of the images out of memory without any storage. So depending on which model you choose, you have different options, but a large number of our customers use it with persistent desktops specifically. Chris, do you want any comments on that?
Actually, no. I mean, I think that's a very accurate assessment, at least from a Washington Trust perspective. We're using the same storage infrastructure, storage mechanisms for both our persistent and non-persistent desktops, which I think from our perspective, at least at this early stage in our VDI experience here, it certainly simplifies things for us.
Yeah, the next question was, you were using, or Washington Trust is using Fiber Channel, and many kind of smaller customers might not have access to Fiber Channel storage. So the question was, can you use other types of storage? And from Atlantis Elio's perspective, you can connect to any storage that's supported by VMware vSphere. So it could be NFS on the back end, it could be iSCSI, it could be local disk, or it could be memory in the case of diskless VDI. So basically any storage you have, the Atlantis Elio virtual machine can sit in front of that and optimize. And often it makes possible using different kinds of storage. So without Atlantis, you might have needed a tier 1 type SAN to power 500 users, but with Atlantis, you could have used some less expensive, lower cost tier of storage, because you don't need as many IOPS and you don't need as much capacity. So the next question, just quickly, how is Atlantis Elio licensed? It's licensed on a per user basis, so you buy the same number of licenses as you would for VMware View, for example, in the case of Washington Trust. Getting back to some questions for Chris. So let's see here. Did you look at any other storage appliances, and if not, why not?
No, we didn't. The short answer is no, for a couple of reasons. One is we had the CX4 available to us, and we had a lot of extra capacity to easily handle this. So the first question is okay, well, let's just leverage the storage that we already have available to us. Secondly, and I think as Seth kind of alluded to here earlier, when we went into this, we weren't thinking about any type of storage optimization products or even a requirement for that, but we were looking as an original goal to get the best performance that we could, to give our end users the best experience that we could give them. And since we had the fiber channel fan, definitely tier 1 stuff, okay, let's use that and ensure, we thought, that we would not have any I/O issues. Because I mean, we know there's I/O is a potential problem with VDI. For us, it's just that we thought we had thrown enough hardware at it to kind of overcome that problem, and obviously we were wrong. Looking back at it now, and what Seth also said about using other types of storage devices, if I were going to start over at this point in time, and maybe as we expand this in the future, definitely be open to looking at some other potential storage mechanisms. However, I just want to add really quickly, one of the things that as part of our implementation here and as part of our overall strategy from an IT perspective, one of the things that we're looking at is, see, we have a secondary data center down in Boise, Idaho, and we are doing SAN-to-SAN replication between EMC SANs. So one of the beauties of having it in the EMC SAN environment is that we can use that SAN-to-SAN replication, and we can replicate these desktops down to our Boise facility. And we have, hosts that are kind of sitting there in a quiescent state. So let's just say, should our current data center, go away for some reason, in conjunction with our MPLS architecture, we can bring up the desktops in Boise just by firing up the servers down there. So that's another reason why we wanted to go with our fiber channel SAN.
Okay, thanks, Chris. If we didn't get to your question, we'll follow up by email. But we're almost 15 minutes over now, so I'm going to go ahead and wrap it up. And thank you for attending the webinar. You will receive an automated email with a link to the recording of the webinar, and we'll post the presentation on the Atlantis Computing website at www.atlantiscomputing.com/customers. So thank you for attending, and Chris, thank you for taking so much time to share your deployment with everyone.
Yeah, my pleasure, Seth, and my thanks to everybody for attending this. Hopefully you found the information useful. I know I would have if early on in our deployment planning.